When a helicopter hovers above the ground, something powerful is happening just below it. A churning, invisible storm called rotor wash. Rotor wash, sometimes called downwash, is the turbulent column of air pushed downward by the spinning main rotor blades. It's what gives the helicopter lift, but it's also the reason dust, debris, and even small objects can be violently thrown outward when a helicopter comes in to land. To understand rotor wash, we have to start at the top, with the main rotor system. These massive blades are airfoils, just like an airplane's wings. As they spin, the blades create a low-pressure zone above them and a high-pressure zone beneath. This pressure difference is what lifts the entire aircraft off the ground. But that lift doesn't come free when it displaces air downward. The faster and heavier the helicopter, the greater the volume and velocity of air it must push. That downward blast is rotor wash. In a hover, that wash hits the ground and splays outward in every direction. Pilots feel it as a subtle vibration. People on the ground feel it as a gale force wind. Rotor wash intensity depends on several factors. Rotor diameter, blade pitch, and engine power all play a role. A light observation helicopter might stir up dust and grass, while a heavy-lift Chinook can flatten small trees and flip tents from 100 feet away. But rotor wash doesn't act alone. It's part of a delicate dance between the helicopter's other major components. Behind the aircraft sits the tail rotor, small but critical. The main rotor doesn't just generate lift, it also creates torque, trying to spin the fuselage in the opposite direction. The tail rotor counters this force, providing stability and directional control. It too produces its own smaller wash, a sideways blast that helps the pilot steer with precision. Then there's the engine and transmission, the heart of the helicopter. Whether it's a piston engine or a roaring turbine, it channels power through the main gearbox, which splits torque between the main and tail rotors. The transmission must manage immense loads while maintaining balance and control. The swash plate assembly, a complex mechanism of rotating and stationary discs, beneath the main rotor hub, translates the pilot's control inputs into subtle changes in blade angle. This allows the helicopter to tilt, climb, descend, or move laterally. When the pilot pushes forward on the cyclic stick, the swash plate tilts, altering blade pitch so that lift becomes directional. The helicopter leans and the rotor wash shifts with it. This shifting wash pattern is crucial for maneuvering. When flying forward, the downwash is swept backward, forming a trailing wake that can buffet nearby structures or other aircraft. During takeoff and landing, pilots must be aware of brownout or whiteout conditions, where rotor wash stirs up dust or snow so thick it blinds them completely. Even the helicopter's landing gear and fuselage design influence how rotor wash behaves. Skid-type helicopters, for example, tend to trap and deflect airflow differently than those with wheeled landing gear. In essence, rotor wash is the visible footprint of invisible physics, a force born from lift itself. It's both a product and a reminder of the helicopter's unique ability to hover, something no fixed-wing aircraft can do. For ground crews and rescue teams, understanding rotor wash isn't just science, it's safety. Approaching a helicopter means staying low, keeping clear of debris, and respecting the invisible hurricane below its blades. From the cockpit, pilots learn to feel the wash, to anticipate how their own airflow interacts with the ground, with obstacles, and with the air itself. Because every helicopter flight, from a military extraction to a mountain rescue, begins and ends in that powerful, swirling rush of displaced air. That's rotor wash, the unseen wind that makes flight possible.